And so I'm actually out at a training today. So I'm recording what we would be going over. Um, we're going to review the video. Well, this is a video. We're going to review Unit 1 quick quiz lessons 1 through 4, which the sub should just have passed out to you guys. I'm going to have you guys sign up for these Ready, Set, Go homework help videos. And then we're going to work on the Ready, Set, Go practice to focus on. There's a list of problems, some of which we've done that I would like you guys to practice on. And then for the remaining time, you're going to work on the Ready, Set, Go practice using the help videos and help pages. Today is Tuesday, so I am available after, I'm not available after school on Tuesday. I am available before school on Wednesday. I'm also available for help after school on Wednesday for your tests, which are on Thursday. There also should be a short amount of time at the beginning of class where you guys can ask some clarifying questions. So go ahead and have your quiz out. We're going to go ahead and go through the quick quiz. So the directions say that we want to specify a transformation or sequences of transformations that fit the verbal description or the picture. So when we take a look at this picture, it's not facing the same way. So if it's not facing the same way, or it looks like it's twisted or it's turned, what's going to be the transformation? Because we got three. What are the three? Yes, they are reflection, they are translation, and they are rotation. So, quick test to yourself. Reflection is a flip, generalized. We now know that there's a lot more specificity behind it. Translation is to slide something, and rotation is to twist something or turn something about a point of rotation. So, reflection and rotation both have something with regards to it that we're going to be looking for. So, this one is a rotation. Now, for ease and purpose on this question, I was just really looking for rotation. Quite a few wrote a lot more. Some of you actually said that we can translate it up one and left, up one, left, 1, 2, 3, left 3, and then rotate around the point -1, +2. We could look at it from that perspective as well. Okay. Or you could just say it's a rotation. If we wanted to get a little more specific, we could go about the point 0, 0. And from there, what we could do is we could count up 1, right 2, from 0, 0 to B is 1/2, which means from 0, 0 to B prime, we want to go up 2 and left 1. So we could see that up 2 and left 1. And then this and this are what? Exactly. They are opposite reciprocals, which actually means it's a rotation about the point 0, 0. It is 90 degrees counterclockwise. But I was willing to accept just rotation. Okay. Now, we get into this idea of the structure that we see with our transformations. So if we have a circular structure, I mean, what's a circle look like? If we have a circular structure, so from our from our point there, if we say here is our initial, any point along here being our pre-image, being an angle of rotation or an angle, what structure or what transformation has a circular structure? Absolutely, that's a rotation as well. A rotation has that circular structure. Notice this distance is congruent to this distance from your center of rotation. All right. This one kind of faces the opposite direction. So like D to D prime, if we actually wanted to, we could sketch, well, we're not going to snap it apparently. D to D prime, C to C prime, B to B prime. Every single one of them does what? You're right. It went down one and left, down one and right one. So that means B to B prime is parallel to D prime, which is parallel to C prime. And if all of those are parallel, what do we know about this structure between them? We know we have a, sorry, that's not real straight line. We know we have a reflection. Now, we could find the line of reflection if they're all like this. The line of reflection is the perpendicular bisector of each of the line segments. So if I count D to D prime, that is halfway in between. So that's that perpendicular bisector. Now the slopes of the original D to D prime is down one, right one. So the slope of the perpendicular bisector is up one and right one. So we could draw the perpendicular bisector. We could also write the equation of that perpendicular bisector. We could pick a point. What's this point? -5, -5. And the slope of the perpendicular is +1. So in point slope form, y plus 5 equals 1 times x plus 5. We could also write it in slope-intercept form, y equals 1x plus 0, because it crosses the y-axis at 0, 0. Okay. All right. This one, I think, got some of us because of the language. Corresponding points from the pre-image to image are equidistant from a defining attribute of the transformation. All right, so corresponding points pre-image to image. So that would be like A to A prime. Okay. So we're going to draw those segments between them. Equidistant is just what it sounds like. It sounds like it says equal distance. So basically they have the same length from the defining attribute. So a defining attribute is something about you that makes you unique. So for us, defining attribute of the transformations. So reflection, rotation, translation. Translation. A reflection is over a line. A rotation is about a point. Translation is just a shift up, down, left, or right, or some combination thereof. So, which of these three transformations has a defining attribute? Something that is part of the actual transformation. Yes, reflection and rotation both are about a specific thing. So a reflection is over a line, a rotation is around or about a point. So when I rotate, let's take this one. When I rotate about that 0.00, there's my 90 degrees. Those two distances are the same. Those two blue distances are the same, aren't they? When I reflect it, notice those two distances. These two distances are the same. Now, from the line of reflection, B to B prime is not the same distance as C to C prime, but the distance from the line of reflection is. So when we look at those words again, corresponding points from the pre-image to the image are equidistant from a defining attribute. Do you need to be equidistant from the line and the center for a reflection and rotation? Yes. So this actually has two answers, both the reflection and the rotation. The image to pre-image are equidistant from the defining attribute. What's the defining attribute of a reflection? A line. What's the defining attribute of a rotation? That point. Translation, it doesn't happen that way. All right. How did I get from B to B prime? Up 1, 1, 2, 3, 4, 5. So I went up 1, right 5. Let's see if we did the same thing for D. Up 1, 1, 2, 3, 4, 5. Same deal for D. Let's check C. Up 1, 1, 2, 3, 4, 5. You can see that this is definitely a translation. I think translations are one of the easiest ones to see because you can just see that movement. Now, which transformation produces an image that is congruent to its pre-image? So we move it. So we either translate it and the image and the pre-image are the same. That's what congruent means. If we rotate it, are the image and the pre-image the same? And if we reflect it, are the image and the pre-image congruent, meaning the same size? Basically, can I cut out an image or a pre-image and rotate, translate, reflect it onto the image? So take a look at this one. Can I move BCD, cut it out, and can I put it on B prime, C prime, D prime? Can I take BCD, cut it out, and put it on top of B prime, C prime, D prime? Can I take BCD, cut it out, turn it, and put it on top of B prime, C prime, D prime? Because those are the three transformations we've had: rotation, reflection, translation. So what is the big idea with these transformations is that all of these rigid transformations all produce congruent images. So that means there are three answers. The three answers are translation, rotation, and reflection. Every single one of them will produce an image that is congruent to its pre-image. All right. Now these disagree-agree statements. It's kind of like a true-false. If we disagree, we need to figure out why. If we agree, we need to figure out why. Okay? If I connect corresponding points of pre-image and image for a rotation, 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 rotation. What does rotation mean? Okay, that's what I want you to think about it. Should we use straight lines to describe the movement? Go back and look at your previous quiz questions. Do we agree or disagree? Thumbs up, thumbs down. Absolutely. We are going to disagree. Straight lines don't make sense for a rotation because what's the underlying structure? Exactly. A circle is the underlying structure. Concentric circles would best describe the movement. Now, could you draw a picture of some sort if you wanted to? Okay. If we had point A, and then we wanted to rotate it 90 degrees to A prime, the relationship that it would see would be a circle from one point to the next point. We would rotate along that circle. So that could be an example of a picture that we might see. All right. And again, because it's a video, stop and pause if you need to write stuff down. Stop and rewind if you weren't sure. Make notes in your workbook or your notebook of questions that you might have to ask. But because it's a video, you can do that. In a reflection, so reflection, corresponding points from the image and pre-image are equidistant from the line of reflection. So what, again, that line of reflection is better known as the perpendicular bisector of the segments between the image and the pre-image. So look back at what we've done with reflection. Line of reflection is in green. Green to C prime, green to C, are they equidistant? Get the symbols. Line of reflection to D prime, line of reflection to D, are they equidistant? The answer is yes, we agree with this one. And what we could show is that we could show, let's see, a line segment, A to A, B, B prime to A prime, line of reflection, this distance are the same. This distance are the same. Now, I'm hoping you would get a rule out and draw better lines than I'm drawing right this second. All right, last one. When we reflect a shape and we connect the corresponding points between the pre-image and the image to form the line segments, are all of the line segments congruent? So that means we're going from image to pre-image. Are those segments congruent? Not from the line of reflection to the points, but from the point to point. Exactly. We are going to disagree. Very clearly, we can see in this one, does A prime equal B, B prime? The answer is no, because A is further from the line of reflection than B is. So therefore, A prime to A is larger than B to B prime. And you can explain that. Okay. If a point is further from the line of reflection, the segment joining image and pre-image is greater than, I can't spell, greater than a segment formed by a point closer to the line of reflection. Okay. All right. Ready, set, go videos. You are going to go into Schoology. Okay. I actually put a link into Schoology with all of the information. So you're going to go into your course. I'm just going to pick 2B because it's easy. You're going to actually use this homework help, ready, set, go instructions. You can click on it. It is a Google Doc. You'll sign in and so on. But when you click in that, that Google Doc will open up this document. It has a link to where you need to go. You're going to complete the registration form selecting OUR High School Math Annual Subscription. You're going to choose voucher and you're going to use Cherry Creek 2425 and click apply. That will give you the access to all the videos for that course. You can also download help, hints, and explanations for each lesson. So when you look at it, this is what it looks like. You're going to select this one, and you're going to put in your Cherry Creek 2425 and apply. Once you're done with that, I would highly suggest taking this link and bookmark the site so you can refer to it as we go throughout the year. Okay. One additional set of things that I think would be good. Use those videos and use this set of focus problems as practice for the test that's on Thursday. So again, test on Thursday. I'm available before school and after school on Wednesday. Okay. If you need help before, after, on Wednesday. Okay. I will also put these slides into Schoology so you can access those as well. So you can see what those problems are. Okay. If you do have questions, shoot me an email. Again, I'm available for help. You could also take this stuff into the CRC during your off period on Tuesday, if you have me second period, or Wednesday, whenever you have an off period. Okay. Have a great afternoon.